The explosion shook the ground. March 7, 1945, 3:16 p.m. Lieutenant Karl Timmermann heard the blast from the western end of the Ludendorff Bridge at Remagen, Germany. German engineers had just triggered their demolition charges. 500 pounds of TNT exploded beneath the railroad bridge spanning the Rhine River. The bridge shuddered. Steel twisted. Concrete cracked. For a moment, it seemed the entire structure would collapse into the cold water 300 feet below. Then the bridge settled, still standing, damaged but intact. Timmermann looked back at his men from Company A, 27th Armored Infantry Battalion. They'd fought their way through the town of Remagen under machine gun and artillery fire. Now they stood at the western end of one of the last bridges across the Rhine. The last major natural barrier protecting Germany's industrial heartland. Behind them, German tanks and infantry were in full retreat. Ahead, across 1,056 feet of damaged railroad bridge, lay the path into Germany itself. Timmermann's radio crackled. Orders from his battalion commander, Lieutenant Colonel Leonard Engemann. Get across that bridge. Take it. Hold it. The bridge was wired with more demolition charges. German defenders held both towers on the eastern bank. Artillery fire was already hitting the approaches. Snipers covered every angle. Crossing meant running 1,056 feet through a gauntlet of fire with no cover. But orders were orders. Timmermann turned to his men and said the words that would change the war. Follow me. This is the story of one of the most critical engineering operations in World War II. It's not about the Ludendorff Bridge itself, though its capture was the miraculous starting point. It's about what happened in the days that followed, when American combat engineers built pontoon bridges across the Rhine River under constant artillery fire, aerial bombardment, and V-2 missile attacks. It's about the 51st Engineer Combat Battalion building a 969-foot heavy pontoon bridge in 27 hours while German shells killed and wounded men around them. It's about the 291st Engineer Combat Battalion constructing a 1,032-foot steel treadway bridge in 32 hours under barrage after barrage. It's about engineers working in freezing water under fire, building the bridges that allowed 125,000 American troops to cross the Rhine and break into Germany's industrial heart. The title suggests engineers built one bridge in 4 hours and crossed 2,000 troops. The reality was far more complex, more dangerous, and more impressive. Multiple engineer battalions built multiple bridges over multiple days, all while under fire. Let's explore what actually happened at Remagen and how American combat engineers performed one of the war's most dangerous and essential tasks. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Rhine River wasn't just another obstacle. It was Germany's last major natural defensive line. Running roughly north-south through western Germany, the Rhine was 300 to 350 feet wide in most places, with swift currents and deep channels. Every bridge across it represented a strategic choke point. By March 1945, German forces had systematically destroyed virtually every Rhine bridge as they retreated. They'd blown bridges at Cologne, Dusseldorf, Bonn, and dozens of other crossing points. The plan was simple. Deny the Allies any Rhine crossings, forcing them to conduct opposed river crossings under fire, the most dangerous of all military operations. When American forces approached the Rhine in early March 1945, Allied planners expected to fight brutal battles to establish bridgeheads. Operation Plunder, Field Marshal Bernard Montgomery's massive set-piece Rhine crossing scheduled for late March, involved 3 armies, thousands of artillery pieces, massive aerial bombardments, and airborne drops. That was what it took to force a Rhine crossing against determined opposition. Then came March 7th. The 9th Armored Division, pushing east as part of Operation Lumberjack, approached the town of Remagen. Nobody expected to find a bridge. At 1 p.m., Lieutenant Colonel Engemann's task force emerged from woods on cliffs overlooking the Rhine, 1 mile north of Remagen. Engemann could clearly see the Ludendorff Bridge, and it was still standing, intact. German soldiers, military vehicles, and civilians were crossing it, evacuating to the eastern bank. Engemann immediately radioed his superior, Brigadier General William Hogue, commanding Combat Command B of the 9th Armored Division. Hogue's response was instant. Get across that bridge. The Ludendorff Bridge was a railroad bridge, built during World War I between 1916 and 1919. Named after General Erich Ludendorff, it had been designed to move troops and supplies to the Western Front. 2 railroad tracks ran across its 1,056-foot span. Recently, German engineers had laid wooden planks across the widely spaced railroad ties to create a roadbed for vehicles. The bridge had 3 spans, 278 feet, 513 feet, and 278 feet, supported by stone piers in the river. Massive stone towers stood at both ends, each 3 stories tall with embrasures for machine guns. The towers could house an entire battalion. On the eastern bank, a 1,299-foot tunnel ran through Erpeler Lay, a steep hill overlooking the river. German defenders were positioned in the tunnel, the towers, and on the heights above. Lieutenant Timmerman led the assault. 22 years old, born in Frankfurt am Main, Germany, less than 100 miles from Remagen, he'd emigrated to the United States as an infant. March 7th was his first day commanding Company A. The previous commander had been wounded the day before. Timmerman assembled his men and explained the situation. They had to cross the bridge before German engineers could detonate the remaining demolition charges. They had to do it under fire from machine guns, rifles, artillery, and whatever else the Germans could bring to bear. They had to do it knowing the bridge might collapse at any moment. At 1:50 p.m., Timmerman's infantry, supported by a platoon of brand-new M26 Pershing heavy tanks, advanced down into Remagen. German artillery opened up. Shells burst in the town. The infantry and tanks pushed through. At 3:16 p.m., as American forces reached the western bridge approach, German engineers triggered the demolition charges. 500 pounds of TNT exploded. The bridge lifted, twisted, settled, but remained standing. The demolition had failed. Why? The Germans had stored the primary demolition charges, military-grade explosives, separately from the bridge. When American forces approached faster than expected, German engineers couldn't retrieve the proper explosives in time. They'd been forced to use donorite, a weak civilian-grade industrial explosive. It damaged the bridge but didn't bring it down. Timmerman didn't hesitate. He ordered his men forward. Company A charged across the bridge. German machine guns in the eastern towers opened fire. Artillery shells burst on the bridge deck. Snipers from Erpeler Lay shot at individual soldiers. Men fell. The wooden planking was damaged, with gaps and craters from the failed demolition. Pershing tanks followed the infantry, but one of the M26s broke through the weakened planking, blocking the bridge temporarily. Infantry dismounted from their half-tracks and ran across on foot. Sergeant Alex Drabik was the first American to reach the eastern bank. Sergeant Joseph Delicio destroyed the main demolition control box in the eastern tower, preventing the Germans from triggering any remaining charges. Lieutenant Emmett Burrows led a platoon up Erpeler Lay to clear snipers from the heights. They fought under concentrated artillery and mortar fire but secured the high ground. By 4 p.m., Company A controlled the eastern towers and the bridge approaches. The bridge was captured. For the first time, Allied forces had an intact crossing over the Rhine. The news electrified Allied headquarters. General Courtney Hodges, commanding 1st Army, immediately ordered the bridgehead exploited. General Omar Bradley, commanding 12th Army Group, called it one of my happy moments of the war. Supreme Commander Dwight Eisenhower altered his strategic plans. Instead of waiting for Montgomery's carefully planned Operation Plunder, American forces would pour across at Remagen immediately. Within 24 hours of the bridge's capture, 8,000 American troops, tanks, self-propelled artillery, and trucks had crossed the Rhine. The 9th Armored Division established a bridgehead 1.5 miles deep and 1.5 miles wide on the eastern bank. German forces scrambled to contain it. But there was a problem. One damaged railroad bridge couldn't support the weight of traffic needed to exploit the bridgehead. The Ludendorff Bridge was already weakened by the failed demolition. German artillery was targeting it constantly. The Luftwaffe was preparing massive air raids. Hitler had personally ordered the bridge destroyed at all costs and had relieved German commanders in the area for failing to blow it. The bridge needed repairs. More importantly, the American forces needed additional crossing points. If the Ludendorff Bridge collapsed, and it was only a matter of time, the entire bridgehead would be cut off. This was where the combat engineers entered the story. U.S. Army Combat Engineer Battalions were specialized units trained in everything from demolitions to mine clearing to obstacle removal. But their most critical mission was bridge building. Each Engineer Combat Battalion had approximately 640 men organized into companies equipped with trucks, bulldozers, cranes, and enormous quantities of bridging equipment. When an engineer battalion received orders to build a tactical bridge, they could deploy multiple types. Bailey bridges, modular steel truss bridges invented by the British that could be assembled from panels without heavy equipment. Treadway bridges, aluminum or steel roadways supported by pneumatic floats. Heavy pontoon bridges, floating bridges using large pontoons with steel or wooden roadways. At Remagen, engineers would build all three types. Within hours of the Ludendorff Bridge's capture, 1st Army Headquarters began rounding up engineer resources. 3 heavy pontoon battalions, the 51st and 291st Engineer Combat Battalions, 2 treadway companies, and a WWII amphibious truck company were all assigned to 3rd Corps. Their mission: build 2 tactical bridges across the Rhine at Remagen as fast as possible. The roads leading to Remagen from the west and south immediately became clogged. Hundreds of amphibious trucks carrying bridging equipment, anti-aircraft batteries, tanks, supply vehicles, and thousands of troops converged on the town. Traffic jams extended for miles. Meanwhile, German artillery observers on the steep hills east of the Rhine had clear views of everything happening on the western bank. They directed fire onto the bridges, the roads, the engineers, and any visible target. On March 9th at 10:30 a.m., the 291st Engineer Combat Battalion began constructing a Class 40 M2 steel treadway bridge approximately 440 yards downstream of the Ludendorff Bridge. A Class 40 bridge could support vehicles weighing up to 40 tons, including Sherman tanks, M26 Pershing heavy tanks, and fully loaded supply trucks. The bridge would be 1,032 feet long, spanning the entire width of the Rhine at this point. Supporting the 291st were the 988th and 998th Engineer Treadway Bridge Companies, providing specialized equipment and additional personnel. These companies brought treadway bridge sets, complete bridge kits developed by the Army Corps of Engineers specifically for rapid river crossings. Each set included aluminum alloy treadway sections, pneumatic floats, connecting hardware, and anchoring equipment. Bridge construction required engineers to work in teams, often in the water, following a precise sequence. First, assembly crews on shore prepared the treadway sections and pneumatic floats. The M2 treadway bridge used aluminum alloy panels. Each panel was approximately 12 feet long and weighed about 400 pounds. These panels interlocked to form a continuous roadway. The pneumatic floats were inflatable rubber pontoons, each about 33 feet long and capable of supporting enormous weight when properly inflated. Engineers connected 3 to 4 treadway panels to form a roadway section, then attached this section to pneumatic floats below. This created a floating bridge module approximately 30 to 40 feet long. Once assembled on shore, crews used WWII amphibious trucks, 6-wheeled vehicles that could operate on land or water, to transport the modules to the river. Other crews used small boats with outboard motors to maneuver the modules into position. The bridge was built from both banks simultaneously, with modules being added and connected end-to-end, extending outward until the 2 sides met in the middle of the river. Each connection point required precise alignment. Engineers had to account for the Rhine's current, approximately 3 to 4 miles per hour at Remagen, which constantly pushed the floating sections downstream. Anchors were essential. Heavy steel anchors were dropped upstream and downstream of the bridge at regular intervals. Cables connected these anchors to the bridge structure, holding it in position against the current. Without proper anchoring, the entire bridge would swing downstream like a gate opening. It was exhausting precision work under the best conditions. At Remagen, conditions were anything but ideal. German artillery fire started immediately. Forward observers positioned on the hills across the Rhine, particularly Erpeler Lay, which rose 600 feet above the river, could see every movement on the western bank. German artillery batteries included 88mm anti-aircraft guns used in ground rolls, 105mm howitzers, and even the massive Karl Gerät siege mortar, a 540mm self-propelled gun that fired 2-ton shells. The German gunners had registered the river crossing sites days earlier, meaning they'd already calculated exact firing coordinates. When American engineers began work, the Germans simply fired at pre-plotted targets. Shells burst among the working engineers with deadly accuracy. Direct hits destroyed equipment, killed men, and slowed progress. Engineers described the sound of incoming artillery as freight trains overhead. The shells made a distinctive whistling roar as they descended. When you heard that sound, you had perhaps 2 seconds before impact. 2 seconds to drop whatever you were carrying and hit the ground. 2 seconds that could mean life or death. During one barrage on March 9th, 17 engineers were killed or wounded. 19 pontoon floats were destroyed, their rubber skins punctured by shrapnel, air hissing out as they deflated and sank. The engineers recovered, brought up replacement floats, and kept working. During another barrage, a shell landed directly in a WWII amphibious truck carrying bridge sections. The truck and its crew disappeared in a flash of fire and steel. The explosion scattered bridge components across the riverbank. Engineers gathered what could be salvaged and continued. On March 10th, a direct artillery hit killed the battalion executive officer of the 276th Engineer Combat Battalion, which had moved up to assist with traffic control and bridge protection, and injured 19 others. The executive officer, a major who'd served since 1942, was coordinating with engineers on the bridge approach when the shell hit. He died instantly. 3 of the wounded engineers lost limbs. They were evacuated to aid stations, then to field hospitals in the rear. The same day, the Luftwaffe launched a massive air raid. 47 German aircraft attacked the bridges in waves. For the Luftwaffe in March 1945, assembling 47 aircraft for a single mission represented a major effort. Allied air superiority was overwhelming. German aircraft faced not only American fighters but also dense anti-aircraft fire. But Hitler had ordered the Remagen bridges destroyed at any cost, and the Luftwaffe obeyed. The air raid lasted 6.5 hours, from mid-afternoon until darkness. Wave after wave of German fighters and fighter bombers, FW-190s and Bf-109s, attacked the bridge area. They dove through American fighter cover, dropped bombs, strafed with machine guns and cannon, and tried to escape. Most didn't make it. American anti-aircraft gunners lined the western bank with flak vehicles positioned side by side, creating an almost solid wall of fire. The anti-aircraft units included quad-mount 50-caliber machine guns on M16 half-tracks, twin 40mm Bofors guns on M19 vehicles, and towed 90mm anti-aircraft guns. They opened fire with everything. The sky filled with bursting shells and tracers, white, red, and green tracers crisscrossing as thousands of rounds per minute filled the air. Pilots described flying through the flak as like flying through a steel curtain. Aircraft were literally torn apart by the volume of fire. American gunners claimed to have shot down 28 of the 47 attacking aircraft. Post-war analysis suggests the actual number was closer to 18 confirmed kills with several more probables. Still, it was a devastating loss rate for the Luftwaffe. The German aircraft that penetrated the flak curtain caused damage. Several bombs hit near the bridges, sending up enormous water columns. One bomb struck the western approach to the Treadway Bridge, cratering the roadway. Engineers immediately deployed with bulldozers and filled the crater, restoring the approach within an hour. The Luftwaffe raid killed 3 engineers and injured 2 others working on the bridges. One engineer was killed when an aircraft dropped a bomb directly onto a supply dump near the bridge construction site. The explosion destroyed bridge materials valued at thousands of dollars and set off secondary explosions that burned for hours. Despite the casualties and constant interruptions, the 291st Engineer Combat Battalion completed their Treadway Bridge 32 hours after starting construction. At 5:10 a.m. on March 11th, the bridge opened to traffic. It was 1,032 feet long and was the first Allied-built bridge across the Rhine. Immediately, troops and vehicles began crossing. The engineers had barely finished when they received new orders. The Ludendorff Bridge was becoming too unstable to use safely. Build another bridge. Fast. The 51st Engineer Combat Battalion, commanded by Lieutenant Colonel Harvey Fraser, was assigned to build a Class 40, 25-ton heavy pontoon bridge 2 miles upstream from Remagen, between the villages of Kripp and Linz on the western bank. This location had both advantages and disadvantages. Advantages. It was farther from the heaviest German artillery concentrations targeting Remagen, and the terrain along the western bank offered some natural concealment from observation. Trees and buildings could hide preparation activities from German spotters. Disadvantages. The far shore hadn't been fully secured yet. German forces still held positions across the river near Linz. The engineers would be building under direct observation and fire from the moment they started. Supporting the 51st were the 181st and 552nd Engineer Heavy Pontoon Battalions, bringing their specialized equipment and expertise. Heavy pontoon bridges used much larger pontoons than the pneumatic floats used in treadway bridges. These pontoons were steel or heavy wood construction, essentially boat-shaped structures approximately 28 feet long, designed to support extraordinary weight. A single M1938 heavy pontoon could support up to 21 tons. The roadway for a heavy pontoon bridge consisted of heavy timber decking or steel plates laid across the pontoons, creating a solid surface for vehicles. Building a heavy pontoon bridge required even more complex procedures than a treadway bridge. First, engineers had to prepare the shore connections, reinforced approaches on both banks where the bridge would connect to land. These approaches had to withstand the weight of tanks and heavy trucks entering and leaving the bridge. At Remagen, the shore connection on the western bank was relatively straightforward because engineers controlled the terrain. The eastern shore connection would have to be built quickly once that bank was secured. Second, pontoons had to be positioned and connected. Unlike the modular floating sections of a treadway bridge, heavy pontoons were individual units, each positioned precisely in the river. Engineers used cables and boats to maneuver each pontoon into place against the current. The pontoons were then connected to each other and to the roadway structure. This required underwater work, engineers diving or working from small boats to secure connections beneath the water surface. In March in Germany, the Rhine's water temperature was approximately 5 to 7 degrees Celsius, about 40 to 45 degrees Fahrenheit. Engineers working in this water could only stay in for short periods before hypothermia became dangerous. They rotated in shifts, working a few minutes in the water, then getting out to warm up before going back in. Third, the bridge had to be anchored. Heavy anchors, some weighing hundreds of pounds, were positioned upstream and downstream. These anchors were connected to the bridge with steel cables. The anchors had to hold the entire structure against the Rhine's powerful current. If anchoring failed, the whole bridge could tear loose and drift downstream, potentially striking and damaging other bridges. The 51st Engineer Combat Battalion began construction at 4 p.m. on March 10th, even before the far shore had been captured. This was extraordinarily dangerous and violated standard engineer doctrine. Normally, both banks would be secured, the area cleared of enemy forces, and defenses established before engineers started work. But the tactical situation demanded speed. The Ludendorff Bridge was showing increasing signs of structural failure. Engineers inspecting it reported alarming cracks in the stone piers and dangerous deformation in the steel trusses. If it collapsed before alternative crossings were ready, the entire bridgehead would be isolated. Lieutenant Colonel Fraser made the decision. His battalion would start immediately, accepting the risks. The engineers assembled pontoon sections on the western bank and began extending the bridge outward into the river. They worked methodically, following procedures drilled countless times in training. First pontoon positioned, anchored. Second pontoon positioned, connected to the first, anchored. Roadway section laid, secured. Moved to the next pontoon. The work was slow and physically demanding. Each pontoon weighed thousands of pounds. Moving them required coordinated effort by multiple engineers using boats, cables, and pure muscle. German forces on the eastern bank could see everything happening across the river. Machine gun fire peppered the work site from the first moment. German MG-42 machine guns, firing 1,200 rounds per minute, raked the western bank. Engineers working on shore threw themselves flat when machine gun bursts came their way. Engineers in the water had no cover. They could only keep working and hope the fire would shift to another target. Artillery shells walked across the river, searching for the bridge. German observers called in fire missions. A ranging shot would land in the water 50 yards from the bridge. Engineers would see the splash, hear the explosion, and no more shells were coming. The Germans would adjust fire again, walking the shells closer to the target. When shells started landing near the bridge itself, engineers had seconds to decide. Abandon work and take cover, or keep working and accept the risk. Most kept working. The bridge had to be finished. German warplanes, what remained of the Luftwaffe, bombed and strafed during construction. On the afternoon of March 10th, 3 FW-190 fighter bombers broke through American air cover and dove on the bridge construction site. They dropped 250-kilogram bombs and strafed with 20mm cannon fire. One bomb landed 20 yards from a group of engineers positioning a pontoon. The explosion threw men into the air like ragdolls. 3 engineers were killed instantly. 2 were wounded, both with severe shrapnel injuries. They were evacuated to an aid station, then to a field hospital. 1 survived. The other died during surgery. On March 11th at 7 p.m., the 9th Armored Infantry Battalion finally captured Linz on the eastern bank. With both shores secured, the engineers accelerated their work. They labored through the night in darkness, using minimal lighting to avoid attracting more fire. The Rhine's current was strong, making pontoon placement difficult. Each pontoon had to be maneuvered precisely into position and anchored securely. The roadway sections, heavy wooden planks or steel decking, were laid across the pontoons and bolted together. Engineers worked in shifts, some in the water, some on the partially completed bridge, some on shore preparing materials. At 7 p.m. on March 11th, 27 hours after starting construction, the 51st Engineer Combat Battalion completed their bridge. It was 969 feet long, a Class 40 heavy pontoon bridge rated for 25-ton vehicles. It was the fastest-built floating bridge ever completed by U.S. Army engineers while under fire. Immediately, it opened to traffic. Tanks, trucks, artillery pieces, and thousands of infantry began crossing. The flow of American forces into Germany accelerated. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By March 12th, 3 bridges spanned the Rhine at Remagen. The damaged Ludendorff Railroad Bridge, the 291st Steel Treadway Bridge, and the 51st Heavy Pontoon Bridge. Traffic flowed continuously. By March 12th, 25,000 American troops had crossed into Germany. The bridgehead was expanding despite fierce German counterattacks. But the Germans weren't finished. Hitler was obsessed with destroying the bridges. He personally ordered every available resource dedicated to eliminating the Remagen crossings. What followed was one of the most intensive attempts to destroy military bridges in World War II. German artillery bombardment intensified. The 51st Engineer Combat Battalion's pontoon bridge came under particularly heavy fire because it was farther from American anti-aircraft concentrations. Shells burst on the bridge deck and in the water around it. Engineers worked continuously repairing damage, replacing pontoons, fixing roadway sections. The Luftwaffe launched repeated air raids. German pilots flew through murderous anti-aircraft fire to attack the bridges. Few aircraft got through, but those that did caused casualties. The Germans deployed V-2 ballistic missiles, the world's first long-range guided ballistic missiles, launched from sites in the Netherlands about 120 miles north of Remagen. 11 V-2s were fired at the Remagen area. These were cutting-edge weapons traveling faster than sound. There was no defense against them. The V-2s destroyed several buildings in Remagen and killed at least 6 American soldiers. But none hit the bridges. The missiles' guidance systems weren't accurate enough for precision targeting. The Germans tried unconventional attacks. They floated explosive-laden barges down the Rhine, hoping they'd strike the bridges. American engineers spotted the barges and either captured them or destroyed them with gunfire before they reached the bridges. The Germans floated mines downstream. The 164th Engineer Combat Battalion had anticipated this and built log and net booms upstream from the bridges. The mines were caught in the booms and destroyed. On March 17th, Hitler summoned SS Obersturmbannführer Otto Skorzeny, Germany's most famous special operations commander. Skorzeny had rescued Benito Mussolini from Italian partisans in 1943 and had led German infiltrators during the Battle of the Bulge. Hitler ordered Skorzeny to destroy the Remagen bridges. Skorzeny organized a naval demolition squad. 7 SS frogmen equipped with Italian underwater breathing apparatus. Their mission: swim down the Rhine and plant mines on the pontoon bridges. On the night of March 17th, the frogmen entered the Rhine 17 kilometers upstream from Remagen. The water was approximately 7 degrees Celsius, about 45 degrees Fahrenheit. Bone-chillingly cold. The frogmen wore wetsuits, but hypothermia was a constant danger. They used oil drums for flotation support and began drifting downstream toward the bridges. American forces had anticipated underwater attacks. The 738th Tank Battalion was equipped with M3 Lee tanks mounting canal defense lights, massive 13 million candle power searchlights housed in armored turrets. These searchlights had been developed for night combat but had never been used in action. At Remagen, they were finally deployed. As the German frogmen drifted downstream, American searchlight tanks illuminated the river. The beams swept across the water, brilliant white light cutting through the darkness. The frogmen were spotted. American soldiers opened fire with machine guns and rifles. 2 frogmen died of hypothermia. 2 were killed by gunfire. The remaining 3 were captured. The underwater attack failed completely. But the Germans achieved one success. On March 17th at 3 p.m., 10 days after its capture, the Ludendorff Bridge collapsed. The structure had endured too much. Months of Allied bombing before its capture, the failed demolition on March 7th, constant artillery hits, and the weight of continuous heavy traffic. Engineers from the 276th Engineer Combat Battalion had been working on the bridge, attempting to reinforce damaged sections. When it collapsed, 28 engineers died. 63 were wounded. 11 were missing, presumed drowned in the Rhine. It was a devastating loss. But by then, the Ludendorff Bridge was no longer critical. The engineer-built bridges were handling all traffic. In fact, engineers were building additional bridges. Bailey bridges, modular truss bridges, were being assembled to increase capacity. By late March, 6 bridges spanned the Rhine at Remagen. The German attempts to stop the crossings had failed. By March 25th, 125,000 American troops had crossed the Rhine at Remagen. 6 entire divisions, the 9th Armored, 78th Infantry, 99th Infantry, 9th Infantry, 1st Infantry, and 7th Armored, had established a massive bridgehead extending deep into German territory. With them came tanks, artillery, trucks, and supplies. The Remagen bridgehead became the launching point for the Allied drive into Germany's industrial Ruhr region. German forces attempted to contain the bridgehead but couldn't. On March 25th, American forces broke out and began their drive east. The title of this story suggests engineers built a pontoon bridge in 4 hours and crossed 2,000 troops. Let's examine what actually happened compared to this claim. The fastest bridge completed at Remagen was the 51st Engineer Combat Battalion's heavy pontoon bridge. 27 hours, not 4. That's nearly 7 times longer than the title suggests. Why so long? Because building a 969-foot floating bridge across a major river under artillery fire is extraordinarily complex. Engineers had to assemble hundreds of pontoons, connect them securely, install anchors to prevent the current from sweeping the bridge downstream, lay roadway decking, install railings, and test structural integrity. All while shells were exploding around them. All while working in cold water. All while men were being killed and wounded. 27 hours for a bridge that length under those conditions was phenomenal. It was a world record. Did 2,000 troops cross in 4 hours? Certainly far more than 2,000 crossed the bridges. But the crossings took days, not hours. In the first 24 hours after the Ludendorff Bridge's capture, 8,000 troops crossed. By March 12th, 5 days later, 25,000 troops had crossed. By March 25, 125,000 troops had crossed. The bridges operated continuously day and night for weeks. Troops crossed in an endless stream, along with tanks, artillery, trucks, and equipment. The engineering achievement at Remagen wasn't about speed alone, though the bridges were built remarkably fast. It was about building under fire, maintaining bridges under constant attack, and keeping supply lines open while German forces tried desperately to destroy. The human cost was significant. The 291st Engineer Combat Battalions suffered casualties during the Treadway Bridge construction. The 51st Engineer Combat Battalion lost men during the Pontoon Bridge work. The 276th Engineer Combat Battalion lost 28 men when the Ludendorff Bridge collapsed, with 63 wounded and 11 missing. Additional engineers were killed or wounded during maintenance operations, repairing damage from artillery and air attacks. Engineers wounded while fighting fires on bridges hit by incendiary shells. Engineers killed while clearing unexploded ordnance. Engineers drowned when damaged pontoons sank. The exact total casualties among engineer units at Remagen are difficult to determine because engineer units rotated through the area continuously. But conservative estimates suggest over 100 engineers were killed, wounded, or missing during the Remagen operations. These men weren't infantry assaulting fortified positions. They were engineers building bridges. But bridge building under fire is among the most dangerous tasks in warfare. Engineers work in the open, often in water, handling heavy equipment, completely exposed to enemy fire. They can't take cover. They can't stop working when shells start falling. The bridge must be completed, so they keep working even as comrades fall around them, even as equipment is destroyed, even as the danger escalates. The engineering units that built the Remagen bridges came from diverse backgrounds. The 51st Engineer Combat Battalion had been activated in January 1943 at Camp Swift, Texas. They'd trained in river crossing operations and had participated in the D-Day landings at Normandy in June 1944. They'd built bridges across the Seine River in France and the Moselle River before reaching the Rhine. Lieutenant Colonel Harvey Fraser, commanding the 51st, was a career engineer officer who'd graduated from West Point. He'd built bridges on 3 continents during the war. At Remagen, Fraser led from the front, working alongside his men under fire. The 291st Engineer Combat Battalion had activated in March 1943 at Camp Swift, Texas. They'd landed at Utah Beach on D-Day and had built bridges across rivers throughout France, Belgium, and Germany. They'd worked under fire multiple times, but Remagen was their most difficult challenge. The engineers who built these bridges were mostly civilians before the war. Construction workers, farmers, factory workers, students. The Army trained them in military engineering, demolitions, mine clearing, bridge building. They learned to work under fire, to stay calm when shells burst nearby, to keep functioning when exhausted and terrified. At Remagen, they proved their training. The bridges they built weren't temporary expedients. They were precisely engineered structures rated for specific weight loads. A Class 40 bridge could handle tanks, trucks, and artillery pieces without collapsing. Engineers calculated load distributions, stress points, anchor requirements. They ensured the bridges could withstand not just the weight of traffic but also the Rhine's current, wind loads, and battle damage. The bridges required constant maintenance. Artillery damage had to be repaired immediately. Pontoons punctured by shrapnel had to be replaced. Roadway sections damaged by tank treads had to be reinforced. Engineers worked in shifts around the clock. While one crew worked on construction, another prepared materials, and another stood ready for emergency repairs. When German shells hit the 51st Pontoon Bridge on March 14th, engineers immediately deployed with replacement pontoons and repair equipment. They worked in the water under continued shelling, replacing damaged sections, reinforcing anchors. The bridge was back to full capacity within hours. The psychological stress was enormous. Engineers knew they were primary targets. They knew every German artillery observer across the Rhine could see them. They knew shells could land at any moment. Yet they kept working. They had no choice. The entire operation depended on the bridges. If the bridges failed, 125,000 American troops on the eastern bank would be cut off, surrounded, and potentially destroyed. The engineers understood this, so they worked through fear, exhaustion, and danger. After the war, several engineers from the 51st and 291st Engineer Combat Battalions received decorations for their actions at Remagen. Bronze stars for meritorious service, silver stars for gallantry, purple hearts for wounds received. But many more received no recognition beyond the satisfaction of knowing they'd done their duty under the worst possible conditions. The Remagen bridges changed the course of the war. The unexpected Rhine crossing allowed Allied forces to establish a bridgehead 2 weeks before Montgomery's massive Operation Plunder. This forced German forces to divert resources to contain the Remagen bridgehead, weakening their defenses elsewhere. When Montgomery's crossing occurred on March 23, German resistance was lighter than expected because units had been pulled away to fight at Remagen. The bridgehead allowed American forces to encircle the Ruhr, Germany's industrial heartland. The Ruhr produced coal, steel, and munitions. Without it, Germany's war economy collapsed. Over 300,000 German troops were trapped in the Ruhr pocket. They surrendered in April 1945, the largest mass surrender of German forces in the war. From the Remagen bridgehead, American forces drove east toward the Elbe River, where they would eventually meet Soviet forces advancing from the east. The war in Europe ended on May 8, 1945. Military historians debate how much the Remagen crossing shortened the war. Estimates range from weeks to months. What's certain is that it disrupted German defensive plans, allowed rapid Allied advances, and demonstrated that Germany's last natural defensive line had been breached. And it was American combat engineers who made it possible. Without the bridges built under fire at Remagen, the capture of the Ludendorff Bridge would have been a tactical curiosity rather than a strategic breakthrough. The techniques developed at Remagen influenced post-war military engineering. The rapid construction methods, the coordination between multiple engineer units, the procedures for working under fire all became part of U.S. Army engineer doctrine. Modern military bridges are more sophisticated, with improved materials and equipment. But the fundamental principles remain the same. Engineers must work quickly. They must work under pressure. They must build structures that can support military traffic under combat conditions. And they must accept that bridge building is one of the most dangerous tasks in warfare. Today's Army engineers study Remagen as a case study in combat engineering excellence. The 51st Engineer Combat Battalions' 27-hour bridge is still taught as an example of what's possible with proper planning, training, and determination. The bridges at Remagen were dismantled after the war. The Ludendorff Bridge's towers on the western bank still stand and house a peace museum. The eastern towers were demolished. The piers that supported all the bridges were removed from the Rhine in 1976 as they'd become navigation hazards. But the legacy remains. Every U.S. Army combat engineer who builds a bridge in combat follows in the footsteps of the men who built under fire at Remagen. The engineers who built the Remagen bridges were ordinary soldiers doing an extraordinary job under impossible conditions. They worked in freezing water while shells exploded around them. They saw comrades killed and wounded but kept working. They completed bridges that made history possible. And when they finished, they moved on to the next river, the next bridge, the next mission. That was their job. Build bridges. Keep the army moving. Win the war. At Remagen in March 1945, American combat engineers did exactly that. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.